Good afternoon. Today I'm going to show you the new features in version 1.10 of Inkjet Recipe Creation Software. Let's talk about our drawing first. It has a couple of features that we haven't seen in the past. The first feature is that instead of arcs, we're now using splines here. That's a spline and that's a spline. This new version supports splines, and of course it still supports lines and arcs. The other thing you'll notice is that there are two different masters here, this one and this one with the little cutout in the outer boundary. And we'll be showing how we can look at the different masters and identify them. The third thing we're going to show is how if your cell has holes in it, we can take care of that when we rasterize by using something that we call de-embedding. So let's go ahead and start our design. The first step is to define glass. I'm going to put in the correct units. I'll say the head is 265 and the scan is 230. I'm going to reduce the DPI only so that it's easier to display. Arc sag does not need to be that high. This controls the cell ordering. Primary direction is horizontal, and then it's going to be zigzag. So now that we've got all that taken care of, let's go through this step by step. We don't need to explode any nested blocks. We'll start with the line linker. We'll select objects. We'll make that a window selection from here to there. And if I hit enter, all right, I'll accept that. It's found all the objects. The first thing you should do is to turn off your original layer. You don't need those anymore. Now that we've got our data linked, we can do de-embedding. So we need to associate this outer contour with these two holes, and rather than mark them manually, we have a module here called poly de-embed. We'll select the same objects with a window. It's going to put it on ACS poly de-embed, and again we're going to go now and turn off the ACS polys because we don't need those anymore. We're going to deal just with the things that have been de-embedded. This has been marked as a parent polygon, and this has been marked as a child. And all that data is stored as extended data, which you cannot see directly, but which we can read in our program. The next step is to define our alignment mark. In this case, it's in the lower left down here, so let's zoom in. I'm going to type int for snap to the intersection of 2 points. Select that point right there. This tells me where that alignment mark is. Now that I've got my alignment marks, I can go to selecting a master cell. So you notice there's a dialog now. I don't have any master cells at all, so I'll just press select master cell, and then I'll use a window from here to there. Enter. I could then find all the matching cells, but I know that I have a second master cell. So I'm going to say select master cell again, and this time I'll go from here to here. So now we have two master cells. Now had I made a mistake with either one of these, I could select it and then erase it. If I want to see where master cell 1 is, I just click on it and it gets highlighted. If I want to see where master cell 2 is, I click on it and it gets highlighted. This allows me to identify the master cells that I defined. It will tell me where they are. It allows me to delete them and recreate them. I don't have control over the name. The name will always be generated automatically. Now that we've got our masters identified, let's find all the matching guys. We select find matching cells, window, and there we go. Let's look at the numbering here. Because my reference was at the lower left, all distances are from this point to the lower left bounding box. Going horizontal first, so we start with 1, 2, 3, 4, 5, 6, but notice that these three are master cell number 2. And then we zig back and go across again, 7, 8, 9, 10, 11, 12. Zig back, 13, 14, 15, 16, 17, 18. So we found all of our master cells, and that's what we expect to have. Now that we've got the master cells, we will export our bitmaps. There should actually be 2 bitmaps. All I have to do is click Save, and it said OK, and it said OK. We ought to take a look at those bitmaps. So here's our first bitmap. You can see the little corners there, and you can see the cutouts. And if I go to the next bitmap, you can see that this one has the half circle cutout. Now let's look at our PDF. We'll export our PDF. And let's view that. Here's our first PDF, and here's our second PDF for the master cell. And this one has the cutout. So the next step would be to export the recipe file. We'll just use the default name, Island Spine Multiple Master. Let's view that. So this has the usual sections. The last section, the halftone section. You notice there's 2 master cells. The row count is 3 by 6. Each type has 9 in it. We define the first master cell. We give the extents box, the file name for the BIMP. The outer polygon has 393 vertices because of the splines. This is new. There are 2 inner holes. The first inner hole has 29 points in it. And the second inner hole also has 29 points. And then we look at the second polygon, and this has 420 points because we have an extra arc in it. Now here's all of our placements. So now I think you've seen the new features in version 1.10, and you should be able to take advantage of them. Thank you.